Hello everyone, my name is Parag and I welcome you all in the new video. Okay, so in this video I'm going to teach you to determine to find the moment of resistance, which is also called as a MR. Okay, so this is exactly this all these things in working stress method, and already I uploaded one video on WSM of the basic terminology of the stress strain diagram. But in this video, I'm going to introduce one new topic which is called as a load carrying capacity. Okay, load carrying capacity is really very important parameter when we are going to determine in a WSM method. Okay, so first of all, the how to determine, I'll going to explain the steps for this. Okay, so first of all, the first step here in the all diagram, you can see the B D, the steel is over up to this is effective cover, this is what the clear cover, this is depth of neutral axis and D minus S, and this is effective depth. Okay, so now I'm going to first of all determine the calculation of the neutral axis. As you know that X is called as the neutral axis, okay, which is the main neutral axis. Okay, wait a minute. Okay, neutral axis, my handwriting is not so good. Okay, so now neutral axis. Okay, so now in that the formula is like bx square by 2 is equals to modular ratio AST upon in multiply by D minus of X. Okay, so this thing what exactly come, I already told you in last lecture. And the critical depth of the neutral axis, which is given by X, it is very simple, sigma CBC upon sigma ST E by M is equals to XC upon D minus of XC. Okay, so these things are for the comparison for the over enforced under enforced section. Okay, so now with respect to the under enforced section and the over enforced section, there is a all these things come like the for moment of ratio resistance come, that means for X equals to XC. Okay, X over than XC. Okay, or X is less than XC. So all these under enforced over enforced balance section, these condition are comes over there with respect to the comparison of the both the neutral axes, depth and critical. But my main thing is that I'm not going to explain this thing in this lecture. I already explained all these things in last lecture. So in this lecture I'm going to discuss with a new topic which is more beneficial for you, where you can determine the load carrying capacity. Okay, in the load carrying capacity you can simply understood what are the steps I'm going to discuss today. So I rub all these things right now here. Okay, so this is not okay, this is not very important, it takes some time. Okay, so wait a minute, let me complete all these things. Okay, so now yeah, we are going to start right now. Okay, so now first thing is that in the determination of the all these things of where we are calculating the load carrying capacity, the first thing which we have to do is determination and calculation of the bending moment. Okay, so first we have to do, we have to calculate the bending moment. So calculate the bending moment. Okay, so calculation of the bending moment is very simple. So it is done by very simple, because if your beam is simply supported, like it is your beam, okay, it is simply supported. Okay, here the all uniformly distributed load is all on that. Okay, suppose it is W. Okay, and that means it is W and it is length L. Okay, so bending moment for a simply supported, that means for simply supported beam is given by, okay, it is given by WL square by 8. Okay, now if it is in a cantilever, okay, if it is cantilever beam, okay, and the W is applied on this. Okay, so the bending moment for a cantilever beam is given by W into L square by 2. Okay, or if it is simply supported and the load is acting, that means with this, if it is also simply supported but the point load also apply with that means W1 and W2, these two things are there, then it is come like bending moment for a simply supported being where the UDL and the point load both things are there. So it is given by WD, okay, that means factored load into L square by 8. Okay, that means UDL load plus WL by 4. WL by 4 is for point load. For this is for UDL and this is for point load. So these are the three things, that means calculation of the bending moment you have to remember for the overall the calculation. Now I go for this is what the bending moment you calculate. Next the thing is that I am going to calculate the total load. Okay, so calculation of total load, which is given by nothing but the value of W. Okay, so how it's done, where the moment of resistance is equals to bending moment. Okay, so this is simple thing. So you got the W in Newton per mm square or kilonewton per mm square. These things will be happen in kilonewton per mm square or Newton per mm square. Okay, so as you get the bending moment, so here the moment of resistance is nothing but equals to your bending moment. Okay, now the third step is that you have to calculation for the self weight of the beam. So calculation for self weight of the beam. Okay, so you have to calculate for a self weight of the beam, that means the dead load. Okay, so you are going to calculation calculation for a dead load. So calculation for a dead load is very simple. That means a self weight is nothing but B, okay, multiply by D multiply by gamma, where gamma is nothing but unit density of the concrete. Okay, density of concrete when used with steel, okay, that means here the steel also and concrete also. This is concrete and this is what, steel. So with concrete and steel you have to determine the self weight of the concrete, self weight of the beam. Okay, so it is also the self weight also come in a kilonewton per meter. Okay, so after that B and you should maintain a main thing is that B and D always in meter also. Okay, and gamma the unit weight also in for a density of the concrete is nothing but 25 kilonewton per meter cube. Okay, so 25 kilonewton per meter cube is a value for the concrete. Okay, so now the main thing is that after whatever we are going, this video is all about the load carrying capacity, that is LCC. Okay, so now first we have what we can calculate bending moment for particular section. Okay, then we calculate the load carrying total load where the moment of resistance equals to bending moment, and then we calculate the calculation for the self weight of the beam with the dead load. Now I wanted to tell you one thing, guys. If you not subscribe my channel, so please subscribe. Okay, and please give like to my video. Okay, and please share it. Okay, I'll make one of my Facebook page, and where you can simply ask me questions. Okay, on my personal Facebook I cannot add you, but I make one Facebook page where you can add me. Okay, where you can ask questions. Okay, so now our step number 4 is that where you can determine where the fourth number step, where the calculation for the load carrying capacity of the beam. Okay, which is for the calculation for the load carrying capacity of beam. Okay, so calculation of the load carrying capacity of beam is really very simple. It is done by, so you have to determine the total, what is the total load equals to. Total load is nothing but the live load plus what is the self superimposed load actually there. Okay, what is the self weight out there. Okay, so don't think about this. I'll just explain you properly. Okay, this thing is not properly. Okay, so now the superimposed load you have to determine. Superimposed load, okay, is equals to what exactly? The total load minus of what? Self weight. These two things we already determined, so is nothing but W minus of self weight Okay, so you have to put all these things and you get the superimposed load. So superimposed load is come in kilo Newton per meter. Okay, so these are the steps where you have to use to determine the calculation of the load carrying capacity of beam. Okay, and these things are really very important. You can simply calculate all these things, and it is not so much of that easy, not so much of that hard. Okay, and you can simply, and this is all about the working stress method. I already put these are the two video which is the basic of the working stress method, and I hope that you all guys can be happy with my all the video. And please visit my this website. Okay, www.civilnotes.com. Okay, this website, okay, there is a double s. Okay, so this website really very important. Okay, and with respect to this website, okay, you can simply follow me. Okay, and you can always get notification with respect to my each and every video. Okay, my video come with after 1 day of the before of the video. So please like and subscribe my channel, and thank you and have a nice day. Bye bye.